Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we're going to be talking about regular expressions. So we've looked at grammars and the Chomsky hierarchy, which are kind of theoretical and abstract. Regular expressions are kind of a programming toolkit that is used, and as the name implies, it's very closely related to regular grammars. They're not quite exactly the same, but as a general rule, things that you can do with regular grammars are things that you can do with regular expressions, but the regular expressions are set up to help programmers. Now, when we use regular expressions in a Scala program, you can go into the API, and there is a class called regex that's in scala.util.matching. And how do we get one of these? Well, it turns out there is an R method on the string, which will give you back a Scala util matching regex. So it's as simple as creating a string and then putting .r. You'll note here that they're using triple quote strings, and we'll see the reason for that shortly. This example kind of shows it. There's lots of backslashes in regular expressions, and you might recall that if you put a backslash in a regular string, that is the escape character. And so it turns out that it's also the escape character for regular expression. And so in order to put a backslash inside of your regular expression, if you're using a regular string, you have to backslash the backslash. And then if your regular expression needed to use your escape, then you would have in the regular expression a backslash of a backslash, which when you convert it to the Scala string, if you don't use triple quotes, will be 4 backslashes in a row, and that just becomes horrible. So a lot of times regular expressions are done using these raw strings with the 3 quotes, and then the .r creates a regular expression for you. And you can also create these in other ways. We're just going to cover kind of the basics of them. To help illustrate this, we're going to do something that's a little bit different. So I want to use this, at least to start off with, I want to create a new, and I'm going to use a feature I haven't used in these videos before, a Scala worksheet. And so we'll put it inside of book code. Yeah, I think I'm fine putting it just inside the top level of book code. The worksheet name, regex. Okay, so we have this file pops up down here. The thing about worksheets is, let's see, val a equals the thing about worksheets is when you save them, when they evaluate, they show you the values of things and their types. So it's kind of like a cross between the REPL and actually writing a full program. You get a lot of the feedback that you're used to from the read, evaluate, print loop, but you get to save things and build on top of them. So this will be helpful for us. And we can see that if we were to take just this simple string and put .r here, when we save and this evaluates, we get, this isn't a string now, this is a regex. Now, Scala's regex is actually written as just a wrapper on top of Java's regex, and so it's helpful to look in the Java API. Java has a package called java.util.regex, and as you can see here, it's not a very large package. There's a matcher and a pattern class, the details of which we don't really care about because that's the Scala library is going to hide that from you. If you actually have to write Java code using regular expressions, you'll come in and look at these more. But the reason that I'm pulling it up is because the pattern class happens to have significant documentation on what is inside of what you can do with Java regular expressions. So regular expressions aren't necessarily uniform across all languages. There are slight differences, for example, between Java's regular expressions and Perl, or the regular expressions that you would use for a lot of Linux commands. Something you might not have known, but in VI, when you hit slash to do a search, and actually most Linux programs, when you hit slash to do a search, it actually doesn't search just for the text you type in, it interprets that as a regular expression. And so these regular expressions give us ways of specifying some simple, basically formatting for strings. So starting off, if you put a character in a regular expression, it recognizes that, or it matches with that character. So in the case of hi there, this would be a very boring regular expression. It would match the string hi there and nothing else. And so, like I said, that would be kind of a boring version of a regular expression to use. You can also put in, if you need to have a backslash character, because the backslash is the escape character, you have to backslash your backslash. And you can put in things for the hexadecimal values for characters and use Unicode in your regular expressions. There and also a lot of the standard things that you get from normal strings, tabs and new lines are possible in here as well. Where things get more interesting is with character classes. So this character class ABC can represent any character of A, B, or C, and you can put hyphens in these if you want a range of things. So for example, a regular expression for a digit could be represented as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be one way of representing it as a character class. Of course, if you use the hyphen notation instead, this can be 0 through 9 instead. It's also because in the case of digits are used so frequently that they have a built-in character class that represents 0 through 9, and that is a \d. The example that was at the top of this page used exactly that, a \d. And once again, this is why we use the triple quote strings. If I try to use a single quote here, I have a problem because it says that's not a recognized escape character. In fact, invalid escape character. And so if I don't put triple quotes, I have to backslash the backslash here in order to make this work. Of course, I really generally don't want to do that. I'll use a triple quote, a raw string instead, and that fixes that minor problem for me. So in addition to building character classes just by specifying the characters inside of square brackets, now notice, because this is here, the square brackets are special, which means if you actually want to include a square bracket in what you're recognizing, you would have to backslash your square bracket. Now, you might be kind of wondering, okay, why would I use regular expressions? And if you come up and you look at, I guess this was in the Java version, this would be a regular expression that recognizes a year, month, and day in the format of four digits followed by a hyphen sign, followed by 2 digits, followed by a hyphen sign, followed by 2 digits. And it would have to come in that format. We could do instead maybe the example of a US telephone number, and a US telephone number might look something like this. So we'll specify the area code, and I want the area code inside of parentheses. Now what we'll find is that parentheses are special, so I have to backslash them if I actually want them to appear in the string. And I want 3 digits there, and then I'm going to have a space, and 3 digits there, followed by a hyphen, and 4 digits there. Instead of calling this digit, I'll call it phone in. So this is now a regular expression that happens to be handy for recognizing phone numbers. Okay, so that was the possible use there. What if we want, so let's keep going through the list of things that we can recognize with this. If I want anything that's not a digit, so sometimes I would want to say, if I had, for example, letters and numbers butting up against each other, I might want to have something for the digits and then something that was not the digits. Turns out that there is a character class for that because this type of application is so common. So a \D is for the not digits. You can also represent this as a caret at the beginning of a character class, and that implies you want the negation. So instead of, whereas this character class is just A, B, and C, this character class is anything except A, B, or C. This is all letters, and then you can also do unions of things and intersections of things. So you have a fair bit of power with how you build your character classes. Turns out the things you're going to use most often are digit, white spaces, and word characters. Note that word characters are not just alphabet. It also includes underscore and 0 through 9. These are the characters that the majority of programming languages allow you to use inside of names. Of course, in Scala, we can also use symbolic names, but for example, Java, C, C++, your names for variables or for methods, etc., have to be built out of these characters. So these are some of the useful character classes that exist. We'll come back in the next video and we'll talk about some more of the things that are available in regular expression.